Hello, this is TelecomTV reporting in from Santa Clara in California in the US, where we are attending the ETSI NFV ISG, seventh such convocation, which is obviously about network functions virtualization. My name is Martin Warwick and I'm talking with Jason Hoffman, who is head of Ericsson Cloud, which is a very profound sounding title.
Well,
Jason.
Yeah, good morning.
Good morning. Could I ask for a start about ETSI and Ericsson's involvement in ETSI? It's evident that NFV has great potential for the global comms industry in general. What role has ETSI played in the NFV story?
I think ETSI's been the lead organization as far as defining what NFV means and common architectures and common approaches. I mean, it's been our main vehicle for communicating with the rest of the community.
How have you found getting on with such a disparate group of individual interests, corporate and technology-wise? It's been said that doing all that sort of been rather like herding cats. Has it been like that in your experience?
Well, I think it's been, you know, a lot of the involvement has been everyone that has been involved from this industry in the space. So there's a lot of normal there. The difference around NFV is you also then have the hypervisor players, which weren't there before.
Yeah.
You have a lot of the sort of x86 players that weren't there before. And so we have a lot of people from almost what you typically call the IT space involved with NFV. So, you know, sometimes that ranges from, you know, people that are relatively new to this type of standards process to people that have been part of it for quite a while.
Yeah.
And yeah, that naturally, you know, creates interesting dialogue. So.
Very diplomatically put. Let's move on. As NFV goes beyond theory and into proof of concept before going to later on to trialing and then eventually commercial adoption, can you share with us some of the examples of proof of concept that you know about within Ericsson that you've been working on, whom you've been working with?
Well, and if you allow me to even step
Sure.
another sort of step back from that around just NFV in general.
Yeah.
I mean, if you look at what we've been doing within Ericsson for many years, you know, the whole approach from a platform perspective is to have a common software platform and a common hardware platform for, you know, all of the applications that run on top of it. And so the whole NFV space is these applications that run. And in the telecom space, very often we've been shipping those applications packaged up with, you know, really practically their own operating system, their own sort of software suites, their own sort of hardware nodes. And so there's already been this trend within the industry, and one that we've been pushing rather hard in the platforms group of common hardware platform, common operating system, you know, common components, common services. You know, where in fact, if you do look at you know, an Ericsson node today, and you look at ones that have completely different functionality, you crack those things open on the inside, they're the same. You know, in the sense of common building tools and common components and a common operating system and sort of a common hardware approach. And so when you think of this natural cycle of standardizing on a lot of these types of common components and really taking a standard hardware approach and a really standard operating system approach, you know, then moving from, you know, sort of a non-virtualized version of a, say, C++ application on Linux to a virtualized version of a C++ application on Linux, you know, technically that's not difficult. And so, you know, we've viewed NFV really as just a natural, you know, progression, you know, of the space. We've spent the last 8 years, you know, really building a common hardware platform, you know, standardizing on Linux, standardizing on common components, you know, creating these sort of like common services. And, you know, we've been building our nodes in those ways for years already. Now to get to your specific question as far as like what people are interested in
Yeah.
from the NFV space, you know, it sort of comes to the, you know, why virtualize question. You know, and virtualizations existed for as long as hardware and software for computers has existed. I mean, the IBM System 370 shipped with virtualization in it. So that you could run, you know, 4 previous generations of IBM software on that sort of common hardware platform. So we've always had to do these things as occasionally hardware outpaces software. Now the interesting thing though in the networking space and the telecom space is that hardware and software actually tend to be pretty well matched to one another. And so in fact, if you're sitting there with a very large sort of core or edge router that needs to do terabits per second, you're going to continue buying that just like how it looks today. Now, if you look at the second reason around sort of convenience and accessibility and agility and flexibility, these ideas that we're all experimenting now, where instead of actually having much more of an appliance-based evolved packet core sitting inside of a data center, this idea that maybe we want to put that hosted in another country so that it's easier when someone is roaming, or we want that closer to the edge, or we're all sort of experimenting with these ideas of just how distributed these systems need to be. Does some of these applications, does it help when they're closer to the RAN? Should they stay centralized? And so a lot of these things, as workloads are changing and use cases are changing, there's certain core applications within that entire portfolio where us and our customers are trying to experiment with where they should be and how they should be configured and so on. And then, in particular, like I mentioned, evolved packet core. I mean,
Yep.
that's a good example of a very popular NFV from just about everyone. It's a very natural thing to sort of virtualize. It is a very natural thing to consume in a traditional appliance type mode if you're trying to do sort of like very sort of high throughput packets through that. But when you're looking at sort of machine-to-machine experimentation and that sort of edge distribution type ideas, then that's been a lot of trials. I mean, so when we look at roughly, probably a third of our customer base is like actively going through some virtualized, evolved packet core type sort of POCs, but they are largely around these type of like machine-to-machine setups and other ideas where they're trying to sort of be flexible and agile and trying to build these new types of businesses.
Thank you. You mentioned first part of your last answer, you were talking about Ericsson and what Ericsson have been doing and so on. I want to ask you about the openness which is supposed to come along with NFV. It's emphasized all the time that to be successful there will have to be this openness, but what's the reality? I mean, we have been around this particular loop so many times in the past in the industry where basically de facto standards arrive through a vendor, through a manufacturer, and they become the accepted norm for that particular thing. But there are many, many disparate standards along this type, and they're not open. So how are we going to avoid getting into that sort of lock-in trap yet again?
Well, lock in a way, sort of a state of mind, in the sense of, well, if someone's truly enabling your business and they're only 2, 3, 4% of your total CapEx spend anyway, you're not really locked in. And so even a lot of what we're virtualizing and from a core network perspective and so on like that, this is not the bulk of spend within operators even, and so on. Now, when you look at the openness question, it's a little bit of this change of delivering, a node where it's, hardware and equipment management, and the operating system and the application, and all the sort of surrounding OSS infrastructure around that, all that gets delivered at one time. And now in the NFV space, they're saying like, well, I'm going to get hardware from someone else, and an operating system from someone else, and equipment management from someone else, and now I want you to come run your NFV on there. That's pretty easy to do in the sense of we have been standardizing around hypervisors, and everyone has been standardizing around, say, x86 and Linux, and so there is natural openness in there that's enabled by that. I think the larger challenge becomes more when some of us traditional telecom vendors are now being told, well, you're only going to deliver the hardware platform or the cloud platform, but we're not going to use your VNF, we're going to use someone else's. And often there's a reluctance of that other telecom equipment manufacturer to now run their VNF on someone else's hardware, and vice versa. I mean, our approach there from the VNF perspective is, we've been going, we're standardized on x86, we're standardized on Linux, but we ourselves are also going multi-hypervisor. We also welcome any other VNF creator to come and certify themselves on our platform. And then our VNFs, themselves, because again, we're supporting multiple hypervisors and the like, and multiple hardware platforms, we're even certifying those on other ones. And so, in a way, it's just us getting used to the type of openness that already exists in the IT sector, where you have an ISV, and an ISV certifies their software on, these 6 hardware vendors and these 4 different hypervisors and these 3 other clouds, and the ISV sort of takes on that effort of doing that. And so I think for our community, it's just getting used to what's really a normal way of working in the IT sector, where you're just functioning like an ISV,
yep.
Versus sort of a full stack provider. That's really the openness challenge, is just to be an ISV, in some ways. And then I think, a very, related issue to that then, that even a lot of our customers now have to get used to, is as these things get horizontalized, then the commercials around this and what's guaranteed around it, and how we typically do, terms and conditions and all of that around, those aren't going to be the same either. So we also have to get used to understanding where these interfaces are and how we sort of openly interact with one another, and really develop ways to figure out basically who's at fault. In the sense of, if a node is constantly panicking and rebooting, it's likely not the VNF's fault. From that perspective, there actually is something going on. Operating systems are what make nodes panic, and them having hardware faults is what make nodes panic. And so we're having to have this openness conversation, not only to take much more of an ISV ecosystem type approach to this that exists in the IT sector, but we also have to take on this openness, because as these things are being sort of horizontalized, how these issues are root caused, and really sort of who is to blame, and who at the end of the day pays, when something goes wrong. We have to figure out how to sort of do that too.
Interesting. A lot of problems there.
Yeah.
What about, we know a lot about the potential benefits of NFV, Jason, but what about the barriers to its adoption? What are they, and how do you think they can be overcome?
Well, I think the main barrier is almost like what I mentioned in the beginning.
Yeah.
I mean, if you tease apart this whole telco grade real time that we talk about all the time, I mean, telco grade really means, high performance when you need it, low TCO when you don't.
Yeah.
They're also secure systems, they're resilient systems, and they're aware of the fact that you're running a business on them. I mean, that's really what telco grade is.
Yeah.
And real time, better word for that is predictable. And when you look at those qualities, those are qualities that any CIO wants in general. And so when we think about those first two of high performance when you need it, low TCO when you don't, high performance when you need it is buying a traditional node. That's what it means. And the truth is that if you even look inside of a lot of traditional nodes, you look inside of there and you see an x86 platform, you see normal sort of hardware acceleration that's there, you see a Linux operating system that's, say, functioning as a hypervisor, and you might even see a containerized application running inside of there. So the internals of that is virtualized. And so even in a traditional telecom node, we're going to see, it's going to be a VNF approach inside of there. But in those cases, it's high performance when you need it. The real issue sort of around sort of NFV is the low TCO when you don't.
Yeah.
Because you can't take a 2U x86 system with a 10 gig card and just slap an application on it and expect that to run your packet core. Because one of your packet cores more than 10 gigs of sort of like throughput.
Yeah.
And so, buy a 12 terabit per second device, or put together, literally, 120 normal x86 servers with a 10 gig card in it. And so when you start looking at those balances, and so I think we have to have these clean segmentations of the, again, like why virtualize?
Yep.
If the hardware is truly outpacing software and this whole big node, that's not what's going on there. Hardware's not outpacing software. It's a very high performance environment. If you need that, you should buy a high performance environment. But if you crack the thing open, it's a VNF inside, basically. You know what I mean?
Yeah.
But it's really this sort of flexibility, agility, convenience, type sort of issue. where people are trying to place this on other hardware that they already have. And the choices there should really be for that choice. It should be a low TCO when you don't need the performance. And so I think it's really getting into that sort of mindset around making decisions.
Thank you. A final question. This is the 7th ETSI NFV ISG meeting.
Mm-hmm.
We know there's going to be an 8th.
Yeah.
And a 9th and whatever on from there. But what's next for NFV? Do you think ETSI is going to remain as intimately involved as an honest broker, as an enabler that it is today, or do you think the time will come when the vendors, the manufacturers will, and service providers even, will take a greater part in a different way, and ETSI will become rather more remote from it?
I don't think so. Because technology cycles are standard. I mean, you go through the cycle of standardizing on technologies, trying to combine these assets down. You try to do this consolidation story so you get high utilization and high density. And one of the methods to do that is to virtualize and emulate where you can. And so we've gone through these first sort of 3 cycles. We've been standardizing a lot of these things on x86 and Linux. We've really been sort of taking consolidation into account. We're now sort of like virtualizing these nodes regardless of whether they're delivered on someone else's hardware or in a native node type fashion. Mm-hmm. And we're sitting there and saying that we're taking automation from this hardware management, equipment management layer of automation to this virtualization layer of automation. And that 4th phase of any virtualized environment then is to automate it and then to govern it. And so if you look at that standardize, combine, virtualize, automate, govern, the truth is you look at a traditional telecom setup, those are all present. And we call a governance environment, and automation is supposed to be what comes from OSS. Right, and so the key thing we're going to have to keep in mind is, we're virtualizing things. We're figuring out what the architecture of these virtual things should be and what the openness interfaces are. Now we actually have to start having a very open conversation about how does this become the highly accessible environment that people want? How are we automating it? How are we governing it? Meaning like how are OSS systems completely transforming as a result of this occurring? And so I think even when you look at that 5-stage, sort of cycle, we're only 2.5 ways through the 5 stages, and we're still going to need an organization like ETSI to help go through the rest of the stages. Because now as we're already say virtualized, and we have VNFs deployed, and we also need common ways of automating it, common ways of governing it. Going back to the issue I talked about earlier of like the common governance is, well, how do I know it's compliant? How do I know it's secure? How do I know I'm getting the SLA that I sort of want? And that's going to require all the interaction with sort of existing OSS systems and the like. And so we're less than 50% of the way through the entire sort of cycle that we have to go through. And that's going to have to continue occurring in a forum like this.
Excellent. Jason Hoffman, thank you very much indeed.
Thank you very much.